Welcome to the EGI video, where we will be discussing the necessary steps to connect your EGI EEG amplifier to BCI2000 and what features are available should you do so. We will run through an example experiment and demonstrate the setup and some of these features. So why use BCI2000? BCI2000 includes software tools that can acquire and process data, present stimuli and feedback, and manage interaction with outside devices. BCI2000 is a real-time system that can synchronize a wide variety of biosignals and input devices, such as mice or eye trackers. If you have an G10 EGI amplifier capable of transcranial stimulation, you can also synchronize with the current injection. It has several modules to manage data, importing and exporting to common file formats for offline analysis. BCI2000 also supports a variety of peripheral devices, such as webcams, microphones, eye trackers, keyboard strokes, mouse clicks, all of which are synchronized with the biosignal data. You can also synchronize to any other marker using the digital input on the amplifier. In this video, we will demonstrate synchronizing finger joint position from a 5DT data clef and the EEG responses from an EGI G10 amplifier using BCI2000. Lastly, BCI2000's framework allows you to easily develop custom experimental paradigms that can be replicated on different biosignal acquisition systems. This in turn means that collaborators will be able to replicate your custom experiments on their own hardware and validate your results. For example, BCI2000 comes with a cursor task in 1, 2, and 3 dimensions that leverages the sensory motor rhythm to control a cursor and move it in space. BCI2000 also has the popular P300 spelling task, which leverages the P300 event-related potential and enables nonverbal communication. In addition, BCI2000 includes a robust stimulus presentation task that can present text, audio, and video, allowing you to design custom experiments that target specific brain areas and investigate specific responses. Now, we will move on to the hardware and software setup. First, we want to verify that you have all of the necessary hardware from EGI and a capable BCI2000 PC. So first get your EGI amplifier, and then verify that you have the network switch box, the amplifier power supply, the medical grade transformer, and the EGI MacBook or iMac. You also need the BCI2000 PC that will be running BCI2000. This computer must have Windows installed and have an Ethernet port or adapter. Now we will verify that all of the necessary cables to connect all the hardware is present. So you need 2 network cables, which are blue in the picture, 1 fiber optic cable, which is orange, 1 power cord to go from the transformer to a wall outlet, 1 power cord to go from the transformer to the iMac, and then you'll need 2 cords, one that goes from the transformer to the switch box, and the other goes from the transformer to the amplifier power supply. And lastly, 1 power cord that goes from the amplifier power supply to the amplifier. Once sure that you have all of the necessary equipment, including cables and hardware, we can begin to plug things in. We will start with the power system, specifically the transformer. The transformer isolates the patient and operator from electric shock and surges, and it is necessary to ensure patient safety. It supplies power to the iMac, network switch box, and amplifier power supply. Next, make sure that the transformer is turned off as indicated by the switch on the front. Then, use the transformer power cord that has a standard outlet plug on one side and an IEC plug on the other. Plug this cord into the bottom right plug on the back of the transformer. Again, verify that the transformer is off as indicated by the switch on the front. Now, connect the EGI iMac with the cable labeled plug type 2 in the image. Next, you will need 2 cables of type 1, the IEC plug cable. One of these cables will power the amplifier's power supply, and the other will be used to power the network switch box. Finally, connect the amplifier to the amplifier power supply with the cable shown in the picture. One end plugs into the leftmost plug on the amplifier, and the other plugs into the amplifier power supply. To connect to send, you need to plug it in and twist the sheath so that the cable is locked into place and cannot be pulled out. Next, we will connect the network cables. These cables allow the iMac, amplifier, and BCI2000 PC to communicate with each other and transfer data. Each of these devices has a network cable that will be plugged into the network switch box. First, we will start with the amplifier. The amplifier connects to the network switch box over a fiber optic cable as shown in the image. Then we will connect the network cables to the EGI iMac, which plug into the back of the computer, and then connect the other end to any one of the 8 ports on the switch box. Lastly, connect your other network cable to your BCI2000 PC, and then to the switch box. After doing this, your network switching box should have 3 cables plugged in, as shown in the current image. Now that everything has been connected, you can turn on the transformer by the switch on the front and the amplifier power supply. Next, boot up the iMac. We will now see how to access the web server from the iMac and verify that everything is connected correctly. Now that the EGI iMac is powered on, you can navigate to a web browser. You should know the IP address of your amp, but if you do not, you can use the terminal and the command ARP-A to list the devices on the Ethernet. The one of the form 10.10.10, that some number, should be your amplifier. And then enter the IP address of the amplifier. For ours, it was 10.10.10.51. And then hit enter, and it should load this web page with some details about the amplifier, the time, and the firmware version, amp server version of the amplifier. If you are unable to load this web page, make sure that all the network cables are connected correctly and everything is powered on, including the amplifier power supply. So now that we've verified that we can connect to the amplifier with the EGI iMac and everything is set up correctly, we can move over to the research PC. And the research PC will be running BCI2000, which I've gone ahead and installed already. You can follow another video at this YouTube for some direction on how to do that. And so I have my research PC connected to the network switch box that the amplifier and EGI iMac is connected to over Ethernet cable. And now I'm ready to configure the IP address of this machine. And you have to do this because if I go to try to access the amplifier web server like we did on the EGI iMac via the IP address, the site can't be reached. So now if I launch command prompt and run it as administrator and type ipconfig, we can see that our Ethernet adapter IP address, the IPv4 address, is this. And this won't work because we need it to be at the form 10.10.10.some number, where that some number is not the last 2 digits of the amplifier IP address. And so we can change this by typing netsh interface IP set address and then name, and we'll have to specify a name. And our name here is Ethernet, and we want it to be static. And then we'll specify this machine's IP address on the Ethernet, and I'll just choose 27 somewhat arbitrarily. Just make sure that the last 2 digits are not the same as the amplifier or iMac's IPv4 address. And we have to specify the subnet mask, which is 255.255.0. And this will be the same for all. And then the default gateway. And we'll just do this. And now if I hit enter and do ipconfig again, you can see that on the Ethernet, our IPv4 address has changed. And now the amplifier web server has loaded, and this will look the same as it did on the EGI iMac. So now you're all set to start running your experiments with BCI2000. So now I'm going to show you how to set up a stimulation montage and configure it with a basic example. And this only applies if you have a G10 amplifier that is capable of transcranial stimulation. If you have a net amps amplifier, you can skip this step. So first, let's note that I plugged in a USB drive into the EGI iMac, and I'm going to use this USB drive to transport the resulting file over to the BCI2000 PC. So let's first launch Reciprocity. And Reciprocity is the software that you use to configure the stimulation. And I'm going to load a head model with file, load Atlas model, and select an age. And I'm not going to go through all of the features of this software. I'm just going to set up a basic example. You can read about all of the features in EGI's documentation. And I'm going to navigate over to available views, go to individual G10 planning. Now we can manipulate this head model and see all of the electrodes. And I am just going to select one and set 60 microamps. And I'm going to move over to another one and make it -60 because they have to sum to 0. Add a current plan. I'm going to call this test. Now that I have this current pattern, I can drag it over here. And I'm going to make it a DC protocol. And instead of 5 minutes, I'm going to make it 20 seconds. So now I have this 20-second stimulation pattern. I can save this plan, navigate to my USB, save it as 20 seconds DC. And now that that's saved, we can check on the USB. We have this stimulation file, a.mcb, that's a package, and we can now eject this USB drive and bring it over to the BCI2000 PC. Now I have my USB drive that was previously plugged into the EGI iMac that contained the stimulation montage file plugged into my BCI2000 research PC. So I'm ready to set up my experiment and my batch file. So I'll navigate to the BCI2000 directory, which I have as a shortcut on my desktop, and open the batch directory, and then scroll down to Stimulus Presentation AMP Server Pro. And I've made a few edits to this. To the command that launches the signal source, I've added this flag that logs the data glove. And now if I launch that batch file, I can go to config and then source. And this is where I configure all of the parameters for the signal source, which is the EGI system. And here you can see I have my server IP populated, the number of channels I'm using. I'm also using a sample block size of 40. And here's where we configure the transcranial stimulation. So you have an option to enable it. And then you have the modulation plan file where you upload the file that we have written to the USB thumb drive. So to do that, we hit the browse button, find the USB drive, and now this .mcb that was previously a package on the iMac is now a folder on the Windows computer. And so I can open this folder, And then inside that folder, we'll find a few different files. And the one we're interested in is plan.mcf. And this is the file that you will upload to BCI2000. And now you can have your expression that triggers the stimulation and an import expression. Documentation on expression can be found on the BCI2000 Wikipedia. And now I can load my my stimulus presentation parameter fragment that presents a series of images that prompts the subject to wiggle each of their fingers. So to do that, we'll hit load parameters, and here is my parameter fragment that I've defined in the BCI2000 directory /parms/finger task. So I'll open that. And now my application is populated with all the information that was in that parameter fragment, and I can hit set config. And I'm ready to run my experiment.